I think I made a mistake, and one mistake, but the principle I thought I conveyed it was correct. Let's see this. This is 1. In other words, and we know that Tmax is always Umax. Right? Because energy is considered. Right? So Tmax over Umax must be 1. So that is correct. Okay? So rewriting this give me 1/2 omega n square a square m is equal to 1/2 k a square. Therefore, omega n square is square root k over. Okay? So another way to get natural frequencies to get a maximum kinetic energy and the potential energy and compare this, then we have omega n squared. If I get a large kinetic energy, that means I have large omega n, of course. Meaning that when I up it you have a question? Oh, sorry. Omega n. Where is it at there? Okay. Now. So, what I have been talking to you is this. There's a law, and we can use Newton's second law or energy principle to get the same governing equation and the same result, but different physical interpretation we can achieve. Right? Different physical interpretation. Different way of looking at the simple biological system. Okay. Another thing I emphasized is you learn many vocabulary that can make you to communicate with the vibrating system. So you have to understand the vocabulary. You have to know the definition of your vocabulary. Okay. Let's then exercise the principle we learned. First example, if I have a assembly of text, there is a wheel, and suppose there is a bump. And the wheel go off the bump if the wheel is rigid. Then the wheel I measure displacement from this, and the wheel has some deformation. And also this would rotate. Okay? So the kinetic energy of this system has two components. One is due to linear motion, and the other one is due to rotational motion. Right? What is the kinetic energy of this suspension system due to linear motion? If I say the mass of this sphere is m, then this must be 1/2 mx dot scale. And then what about the kinetic energy due to the rotation over here? Okay, I need coordinate, right? So I say this is the theta. And then I know that the kinetic energy of this field is 1/2 j theta dot scale, and the j is, what is j? J. What is j? Mass moment of inertia. Can you write this mathematically? Right? That is mass moment of inertia. And noting that x equal r, theta, denoting this is r. Assuming that the wheel is not separated from the bump, just to go over and smoothly rotate then the bump, right? And I can write this as 1/2 m x dot scale plus 1/2 j x dot over r scale. Okay? What about the potential energy? Potential energy due to spring. Hey, there is the potential energy increase due to the gravitational force field, right? Potential energy gravitational. But this is assuming to be negligible compared with the potential energy of linear spring, and that can be written as 1/2 k x. Now, I say the kinetic energy plus potential energy is constant. We can again obtain the governing equation. The reason why we illustrate and we use this example is because this system is much more complicated than the system we have learned before, spring mass system. Because there are two coordinates involved. But by using energy principle, we can easily handle the vibratory system that has two coordinates. Otherwise, if you look at this system by just using Newton's second law, we have to draw the free body diagram and so on, so on. Of course, that is useful, but using energy principle that has a simpler kinematic chain, it certainly has some advantage of using energy principle. A very long natural frequency, 5 minutes.